Hello, everyone, and welcome to episode number 69, in which we're going to evaluate some cluster API distributions with my very good friend, Nicholas Lane. Is going to be
Hey, did you say it's episode 69?
It is
Nice.
episode 69. Nice, exactly. Yeah, it's a very good. It's a very good episode number.
Yes, for sure.
But this is So let's dig into our normal opening up. So if you are watching this anywhere, go ahead and leave a comment. Let me know you're out there. It'd be lovely to see who's logged in and saying hello. So if you're out there, go ahead and say hello. And then we'll move right into the news, and then we'll start getting into like kind of the meat of the episode around cluster API and those sorts of things. So Nick and I were just peeking at the news this week, and I have to say, I'm kind of impressed. There's a lot of really good stuff in here. Bill has been doing just a bang-up job of gathering content for the weekly newsletter. And if you haven't checked it out, the way that you can get to the news, if you want to come check it out, is if you go to isogo.to/echo-news, and then a number. The most recent one is number 19, but you can go all the way back to episode Echo News 1 in this way. So there's always, I think it's like, isn't it every 2 weeks, or I think it's about every 2 weeks he puts it out.
Yeah, I think it's every 2 weeks, yeah. And
then once you get there, I think there's like a subscribe link at the bottom or something like that. Or maybe it's on sign up today. Yeah.
Yep.
So if you want to check it out, definitely come check it out. It's a really good news piece. And it's set up in a similar way to some of the other ones that I've seen out there, in which they break it up, in which Bill breaks it up by section. So there's a section that's all about technical articles that are happening in eBPF and those sorts of things. And then he's got the ecosystem, what's actually happening kind of generally with partners and other things that are happening in the space. And then we have the how-to, and then we have events. So lots of really good stuff.
Yep.
Jumping into it, we at Isovalent spend a good amount of time at the Linux Plumber Conference every year, probably because there are so many kernel developers inside of the Isovalent working on eBPF and networking and all kinds of other good stuff. And so it's a pretty big event. I think it's like, what are the other big ones? So we have eBPF Summit, which we just did recently. We have KubeCon, of course, twice a year. And then we have eBPF Day, which happens right before KubeCon. And then the other one, I think that like the dark horse on this list is definitely the Linux Plumber Conference, because I know that quite a few folks on our staff are focused on getting out there and doing this show.
Yeah, it's a conference that I hadn't really paid attention to prior to joining Cilium, but it is definitely one that we value a whole lot, and I can see why. Like it's a really good conference. It seems, looking through the list, like I was just looking at the YouTube list, there's a lot of great talks coming up, or have come up, I should say. So I highly recommend checking out all these videos. Like this is a great conference.
Yeah, definitely. Got a bunch of eBPF videos in here. And the Linux Plumbers Conference is also kind of broken up by sections. So you'll see like parts and pieces and parts that are focused on particular areas or subsystems of the kernel, eBPF just being one. But there are quite a few others that are really pretty interesting.
Yeah, for sure.
I've seen in the past like some really great episodes or some really great videos that were like looking at things like, there'd be like some particular CVE that was in the Linux kernel or in some subsystem of the Linux kernel, and they would I've seen episodes or I've seen videos where like one of the Linux kernel developers was like, all right, let's sit down and figure this out. Let's really take a look at every piece and part that this CVE is touching and really get into it. And I have to say, I've learned so much from those sorts of situations, both in how these things are mitigated, but also like if you're curious, just in understanding the way the Linux kernel is developed and what some of the and kind of the chaos that's happening, right? Because there's like a lot of contributors to the Linux kernel, and the thing is moving fast, and it's been moving fast forever. And so as you get further down, as you look at how these things happen, time of attack to time of first use attacks, those sorts of things, it's been really fascinating watching those things get addressed over time.
Yeah, for sure.
But definitely check them out. Lots of good eBPF talks in there if you are interested in checking those things out, and also just a lot of other great stuff about the Linux kernel. The next one we have is Cilium network configuration for Kubernetes, in which Mike Levin here breaks into like how does Cilium actually remove kubeproxy, and why does kubeproxy why do it, right? Like, so this is actually a pretty good one because, hey, check it out. He's actually talking about how you leverage kubeadm to not deploy kubeproxy. This is a relatively new feature in kubeadm. We're going to talk a little bit more about kubeadm here in a bit, but kubeadm is tooling that allows you to take basically a set of servers and turn them into a Kubernetes cluster. And those servers could be VMs, it could be containers, it could be pretty much anything, but like you just need something with like a system init process, and you can use kubeadm to turn these things into it. And so if you've ever done like Kelsey Hightower's like Kubernetes the hard way, or if you've heard of it, right? This is Kubernetes the reasonably easy way, right? Because it's like command like kubeadm init, and then what happens in the background is all that certificate generation, laying down of configuration onto the file system, creating system D units, starting them, making sure that they did start, like pulling down images. There's tons of stuff that happens behind kubeadm init, but
so
it's pretty cool.
You mentioned Kelsey Hightower. That I never heard of this person.
Wow, yeah, popular. Good dude.
Yeah, but actually, one thing I want to specify, something that one of the workers of kubeadm, or one of the creators of it, specified is like, I want kubeadm to become known as Kubernetes the right way.
Yeah,
because there's the hard way, which is a great learning tool for learning the ins and outs of like what it actually takes to get a Kubernetes cluster running from literal nothing. But kubeadm is a really awesome tool that does all this stuff for you. But also one of the things that's super important about it is the cert generation and also cert renewal functionality. It really simplifies the management of a Kubernetes cluster holistically. So super huge shout out to kubeadm. We will be talking about it later because we will be using it on today's episode. But this is a great blog for sure, blog post. I think there is a good gap of understanding of like what does it take to replace kubeproxy. Like, what does kubeproxy do? What does it take to replace it? And how do you do it? Also, one thing, a huge shout out is the skip phases feature of kubeadm, which I can imagine trying to do this back in the day when everything was basically like kubeproxy was hard coded into Kubernetes. Getting rid of it would have been much harder. Now that we have like everything's broken into add-ons and phases, it's so much nicer.
It's really cool. I mean, the phases thing is really pretty neat, a pretty neat feature of kubeadm in that you can like, the individual things that happen behind kubeadm are just basically a whole series of phases and add-ons. And the skip phases piece, basically, like you said, just says, do all of them except for this one.
Yeah.
Skip this particular phase. But what you don't see is that list. I mean, you know this because you work with it, and so have I, right? But like, what you don't see is behind that in init, there's like 10 or 12 phases.
Oh,
like, that,
all these things you totally wouldn't see.
Pretty cool.
Yeah. Also, Tracy says, kubeadm, get out of here. You get out.
What?
It's kubeadm.
kubeadm. You heard me.
I'm a kubectl boy as well.
Was that Tim that said that? By the way?
That was Tracy. Tracy said that.
No. I mean, the person who said that kubeadm should be is Kubernetes the right way?
I think it was Tim.
Probably. It does sound like.
But also, I'm not going to put. No, it's not kubectl. Get out of here, Tracy. You get right out of here. I also don't want to put words in Tim's mouth. I thought it was Tim. It may not be Tim.
Yeah. Nice. So then we have high performance GeoIP blocking in eBPF with XDP. Basically, just once you've determined like what the IP block, what region that IP block is in, you can probably use XDP to drop that stuff before it gets past the NIC, which is pretty interesting. A practical guide to capturing production traffic with eBPF, using an eBPF-based protocol tracer for HTTP session traffic. This is something that we actually integrate into Cilium. So if you're using Hubble Observe, you have the ability to basically use our eBPF-based protocol tracer to take a look at what's actually happening with HTTP traffic. And that's moving more and more toward eBPF. A lot of folks actually rely on things like a sidecar or Envoy to do this deep packet inspection to really kind of see what's happening. And we did for quite a long time, but nowadays we're actually moving right into the eBPF space for it.
Yep.
Effortless Kubernetes observability with Otigos and Grin. Compiled languages will be instrumented using eBPF. Great to see another observability tool. We have yet another observability solution. I liked your comment. It's like maybe we need an I in here or an
Yeah,
OI.
and observability. Yeah, what could that be? So 'cause I wish it was yet another eBPF observability intelligence solution, so that it could be ya boys.
Ya boys. And then the ecosystem, we have our post that came out November 4th. Mr. Bill Mulligan put this up. He was talking about our Cilium at KubeCon and a wrap up. Lots of great pictures, lots of good content, lots of really big stuff happening with the project, and I'm super excited about it. Basically, Azure picking Cilium as the underlying data plane for AKS, which is super exciting. And then we also have, I'm actually planning on doing a series on this also. I'm in chats with the folks at Grafana to like get some folks to kind of come and be a part of the series, but I'd love to get them out here and like talking about the integration and how we go about it. But there's a great blog deep diving into how the integration works, written by Dan and a bunch of other folks here. But the intention is, right, like with Cilium, you have the ability to expose quite a lot of context and information about what's actually happening at the network layer. And with this integration, we're actually able to, I have to step away from my computer for just a moment, but with this integration, we're able to actually take all of that data and make really interesting visualizations of this data, right? And so I'll let you talk about this for just a moment while I come right back.
Yeah, this is one of the things that I'm very excited for the future. The Grafana integration and like becoming like a, I don't know how to phrase it. Just being like fully integrated with Grafana, like making it much easier for users to like gather data and visualization from Cilium is super, super awesome and really, really powerful. I'm very excited about this. And the Azure stuff also, really quickly going back to Azure stuff. I worked on that a little bit. So I was happy to see that got announced and we're being chosen by Azure. It's pretty great.
Yeah, it's really good. And it really highlights something that I think we don't really talk enough about, which is that, like, when you compare the observability that we build with Cilium, its entry point is just materially different, right? Like at the eBPF layer, at the kernel layer, we have so much more information about what's actually happening, and we can express it in ways that make it possible to find really interesting and hard problems in infrastructure.
Yeah.
Whereas, like, if you look at some of the other tools that we're compared with, like, they only do network inspection. So if the information that you're looking for to try and troubleshoot or understand isn't available in that deep network packet analysis, then it's not available. You can't see what's happening at the layer, right? And so with eBPF and with like what we're doing with Hubble, we can actually do this both at the application and the network layer, providing you like correlated data, letting you really get a holistic picture of what's happening. And that's, I think, the big power of this particular partnership, is that, being able to visualize a more holistic picture of everything that's happening. It's just incredibly cool.
Yeah, I can't agree more. Honestly, the observability portion of the eBPF is what got me interested in it in the first place. Like being able to like gather all that data from like the network layer, both, at the like CNI level, but also at the application level and beyond, right? That power was very interesting to me. And so it's really cool to see Grafana like joining us on this journey.
Yeah, agreed. And then we have something that happened live on stage at KubeCon this year. Cilium applied for CNCF graduation, which means that basically there are enough adopters and enough people using the Cilium open source project that we can move into the graduation phase of the CNCF project that we're a part of. But just a lot of really great stuff happening. So this was a blog post talking about our wrap up. So if you want to come check that out or see what we were up to while at KubeCon, definitely come check it out. Parka is now a part of Grafana Core. Lots of other great stuff. I think we should move on. There's a couple of tutorials I wanted to point out before I go, which is this tutorial here in the how-to on Azure CNI powered by Cilium. So you saw the announcement, but if you want to learn how to do it, you can actually go through this process and do it and do it manually. Create an AKS cluster leveraging Cilium, Azure CNI. So definitely come check that out if that's something of interest to you. And then I think that was all I wanted to point out, but lots of really good stuff. All right, next in the list. Now that we're done with the news, let's play with some technologies.
Sounds good.
So, yeah. So let's get started. Let's get started here. I'm going to start off with by kind of addressing a couple of different questions. So kubeADM was a project that came first, and I mean in the scope of this particular conversation, because we're going to be talking about Cluster API and kubeADM. kubeADM came first. It was a project that was meant. It's actually part of the Kubernetes code base itself. So it's not like a special interest group or like a divorced part of Kubernetes. It's actually built into the product. And this product is meant to give you tooling that allows you to create that cluster leveraging kubeADM, like I said before. And if you go to the docs, if you want to see the docs on kubeADM, you can actually find those docs directly in the Kubernetes documentation about how to install Kubernetes with deployment tools. And there's a whole section here talking about leveraging kubeADM to handle the creation of stuff. Right? Like what your minimum requirements are, like what kind of packages need to be laid down on the host before you start. Lots of good information here.
Yep. And kubeADM basically took over the world when it comes to creating Kubernetes clusters, right? Even Kops runs with kubeADM under the hood. It is now the number one way to instantiate a Kubernetes cluster that isn't a managed cluster, I should say.
Yeah. I mean, and even if you look at say for example, if you look at some of the other implementations of Cluster API, Cluster API for EKS Anywhere, right? They leverage kubeADM under the covers. You look at some of the other ones, and there's a ton of other examples out there where folks are leveraging kubeADM to do the bootstrapping of things. And the reason for that is because it was community driven, and everybody could actually kind of get the flexibility that they wanted into how to create these clusters. This became very quickly the right way to handle this problem. So kubeADM was a great way to handle the instantiation of your Kubernetes cluster, join workers, and do all of this stuff. But what it doesn't do is it doesn't integrate. It's not responsible for making a call to create a new machine or to integrate with necessarily your cloud provider. Right? It doesn't you have to actually already have machines and already have them ready to go before being able to make use of kubeADM.
Mm-hmm.
And so at some point, I remember conversations with Chris and Tim and a few other folks, and talking about how do we go, can we take the ideas of Kubernetes, like a deployment, a replica set, and these pieces and parts, and extend that Kubernetes API to understand the infrastructure on which we can create Kubernetes clusters? Can we solve that problem too? And that's where, in my opinion, Kubernetes Cluster API comes in.
Yep.
And this is basically the idea that we have infrastructure, infrastructure-based API, or have infrastructure API endpoints like AWS, Google Cloud, Oracle Cloud, all of the different API-driven stuff. And so the idea was can we build an API that sits in front and allows us to kind of define the abstraction layer such that you can have this generic idea of a cluster and a generic idea of a machine, and then have providers that are on the back end that handle all of that work of going and talking to those API endpoints. So in AWS, if I say I want a Kubernetes cluster, then under the covers inside of a Cluster API, that means that I will need so many nodes to be a control plane. I need so many nodes to be worker nodes. I need to be able to go and interact with your AWS account and create these machines, create load balancers if I need to, do all of the work of actually standing up and maintaining a Kubernetes cluster, and further handling the upgrade and lifecycle of these things, right? Just like kubeADM handles the lifecycle of your Kubernetes cluster, you can use kubeADM to do upgrades. can we also do that for these machines, right? Can we handle the scaling of a Kubernetes cluster? And can we scale it up, scale it down, create different worker pools, and all of that stuff?
Yep. And so one of the things that was really awesome with the creation of like the cluster API. So cluster API came first, right? The idea of we need some API that can tell infrastructure providers how to create things. But the nice thing was that the infrastructure providers themselves, being part of the community, wrote their own parts of cluster API. So the people who own and know the most about AWS and running Kubernetes on AWS, they wrote the infrastructure pieces for cluster API AWS. Same with Azure. Same with GCP, like and KubeVirt and Rancher. Well, all the other ones. So it's really awesome to see like these people coming together, everyone like kind of believing in this thing, being like, yeah, we can totally do this, and then like making this manifest in the way that like works best for everybody. It's really, really cool.
Yeah, I agree. And I think partially because there were so many people working on it, and because it was such a wide-ranging and monumental effort, I think it took forever to get out of alpha. So now we're finally in the beta releases, but like it took
a long time,
like 4 years, 5 years.
Like, so we started talking about cluster API back in the Heptio days. So that was like 2018.
Yeah.
Even earlier, probably 2017,
Okay,
2018.
maybe it's been more like, yeah, I guess what is time anyway?
Yeah, what is time?
2022 now.
What is time? Baby, don't hurt me, yeah. No more. But yeah, so now it's like 4 or 5 years later, and now we're in beta.
Yeah.
There was a lot of work that had to be done to make this work. Gonna be honest, I'm very impressed with the work that has been done. Like, because I'm using Cluster API AWS right now and Cluster API Azure, and they work, and it's great.
Yeah, it has come a long, long way. And one of the more recent adds is this whole idea of cluster class, which is an experimental feature. But now with cluster class, you can actually understand a new way of creating clusters, which reduces the boilerplate and enables flexible, powerful configuration of clusters, which will be pretty interesting. So this is probably like, how you can handle that thing like skip phase into different things, or into your cluster, that sort of stuff. So that is kind of a high level overview of what Cluster API does and what kubeadm does. kubeadm is the bootstrapper, and it is a provider inside of Cluster API that handles, once you have machines, Cluster API will actually use the kubeadm bootstrapper to turn those nodes into what they will be, either a control plane node or a worker node. And then you can also, again, use Cluster API to handle the upgrades of clusters, depending on what you're doing as well. So pretty cool. So now I want to talk about like implementations of Cluster API. Of course, there are quite a few implementations of OpenShift, where's my brain today? Of Cluster API.
That's the one you're looking for.
Yeah. So, and actually, it's even in the book, right? So if you go to the Cluster API piece here, and you go to concepts, it'll break down like what an infrastructure provider is. This is basically the piece that like interacts, that turns those high level constructs, a cluster, a machine, those sorts of things into real material things. That's your infrastructure provider. Your bootstrap provider is like, how do I get those machines into a Kubernetes cluster? It has the idea of a control plane, which is the responsible, the thing that's hosting your API server, your controller manager, all of those bits. Machine deployments, machine sets, these are all the pieces and parts of a Cluster API high-level order object. But then when you go down into the detail here, you can actually see what some of the providers are. So these are the common providers for Cluster API, right? So we have AWS, Azure, CloudStack, DigitalOcean. There's actually one for Docker where you can actually leverage Docker. And it will basically create kind clusters for you, which is pretty cool. For me, that isn't quite what I need, but we'll talk a little bit more about what I'm trying to do here in just a minute. There's a provider for Equinix Metal, for GCP, for Hetzner Cloud, IBM Cloud, KubeKey, which is not something I've actually played with. I wonder what KubeKey is.
Yeah, I don't know.
With that one?
No, not at all. Let me look it up.
Actually, I haven't played with that one. KubeVirt, which is one that we're going to be playing with. Metal 3, Nutanix, OCI, OpenStack, Outscale. Just there's a ton of different ways to manage this. And basically, the promise of Cluster API is that when you create a cluster or a machine, that all of these providers have implemented that piece of it. Oh, cool. Okay, so it actually merged. Nice.
What's that?
Well, when I was playing with this a little bit earlier in the week, I was trying to, bring up Cluster API KubeVirt, and all this quick start documentation that is here now talks about install Metal LB, install KubeVirt on the kind cluster, do these things, and then you can start spinning up your KubeVirt clusters. This documentation was not present in main yet.
Oh,
so
really?
Yeah.
That's funny
So
because I was just looking. I was looking at this earlier today, and it was all in there. So I was like, "Oh, perfect."
Yeah. So I have a link to the pull request docs, which is here, which basically have all of that same information, because I was reading the pull request to see if it would actually allow me to understand how to make this work. But we'll get to that later.
Really quickly, an update on KubeKey. I had heard of this. It is a mechanism for installing K3s, and KubeSphere, which is KubeKey is a sub-project of KubeSphere.
So as a provider, I'm all curious now.
So it's going to spin up a K3s. It's Cluster API K3s, essentially.
Got it. So it's a bootstrap provider, which is confusing because in the docs here, it looked like, let's see, where is it? Yeah. It's looking like it's a provider, not a bootstrap.
Yeah, it's a little bit confusing, right?
Maybe it's a typo. Maybe it's in the wrong place in the docs, but KubeKey appears to be let's take a look at the provider.
Hey, we're on the same page. Sorry to distract you.
And related cloud native add-ons. So that sounds like it's a bootstrap provider.
Yep.
Oh, and then KubeSphere itself is the Linux distributions. Where do you make the machine happen? What is the machine? Yes. Create cluster where? Where are these nodes?
What the hell? This might be something we need to look into, spend a bit more time on.
Yeah, I'm curious about this because it does look like we've got quite a few people who are in there writing the code. I'm curious about it myself because I don't understand what the hypervisor or the API is. What is it interacting with to create machines? That's where I'm.
So if you go to the KubeSphere itself, KubeSphere/KubeSphere, that says the container platform tailored for Kubernetes multi-cloud data center and edge management. So it looks like it might just be like an API, a control plane for control planes, essentially.
It's a front end. It's similar to the VMware thing.
It actually sounds kind of exactly like Cluster API.
Yeah. But what is the piece? They actually support Cilium installation. I'm going to play with this one a little bit as well. I'm actually kind of curious about it to understand what the VM is. I don't.
Yes. Yeah. What is?
That's
what
not
is
jumping out of me.
Yeah. What are the compute instances? Because it says that it's a distributed operating system for cloud native application management using Kubernetes as its kernel. That is a very confusing statement.
Yeah. Interesting. Well, I'll come back to that later.
Yeah, that's worth exploring.
Yeah. I'm going to close this because I don't need it. I'm going to come back over here.
Anyway, sorry for that.
That's all right. I'm just super curious. Like, do I create VMs and then associate them? Like, kind of wondering like where they're going with that. But anyway, so we've talked about this piece. We've talked. Oh, and then we're talking about the different implementations. So what I was just showing you in the cluster API side is all of the ones that are marked provider in the cluster API side of things. But there are also other implementations of cluster API which are interesting. For example, Amazon's EKS Anywhere is a cluster API implementation. So all of the features and functionality of cluster API, you can actually get right into it here with EKS Anywhere and see how that works. And if you're curious to learn more about that, you can actually follow this link and it will take you to another eCHO episode where I explored EKS Anywhere with Justin Garrison, who is at AWS. And there we spent a bit more time. We spent a bit of time on basically spinning up EKS Anywhere, leveraging kind clusters. And it was pretty neat how it actually worked. EKS Anywhere, of course, has chosen Cilium as the default data plane. So when you create an EKS Anywhere cluster, you're going to get Cilium under the covers as well. As did Google Anthos. So Google's Anthos product is, again, a cluster API implementation. This one is particularly interesting because I've actually stood this one up locally on VMs. And the way this one works is that you kind of like, you can tell it what machines you're going to use. And this is like, I mean, by and large, this is cluster API Ansible.
Oh, interesting.
Because like what happens is you tell it which machines are the control plane nodes, you tell it which machines are going to be the worker nodes, and then you give it credentials to go and log into all of those things, and then you spin it up or you init it. And then what happens is it will literally go in and run a whole bunch of Ansible playbooks to create an Anthos cluster and manage it. And so since it's still cluster API, you still have the ability to like continue to grow that and scale it up and scale it down. It doesn't really interact with necessarily an API per se. I think that actually now it does, but at the time it was really just like, you would give me a list of machines, you would tell me where they are and how to log into them, and then I would go and run Ansible and do all of these things to it to turn it into a cluster.
That's really interesting. Is it actually Ansible under the hood?
Yes, absolutely.
Oh, cool. Yeah. I'm glad someone's still using Ansible.
Yeah, and they still do the same thing where they spin up a kind cluster as a bootstrap cluster. They use the bootstrap cluster to interact with all of the different pieces. They fire off workers to like do Ansible things to all of the different nodes. Like that's the machine implementation, and then they spin the whole cluster up and away you go.
Huh.
Maybe I'll do an episode on that sometime soon.
That is very interesting. I know the logo for cluster API is like turtles on turtles on turtles, but I feel like that's like we're talking about like provisioner on top of provisioner on top of provisioner.
I was not expecting cluster API Ansible, but it actually does work. I mean, it does work, and you could tell it like there's been some pretty significant engineering behind the covers to make all of this work the way that it does. And it works pretty well.
Yep.
And then we just talked about all the different providers that are native to cluster API. And again, this is just kind of a way of searching those things that are made available inside the sig.kh.io, but there are also just a bunch known in the docs themselves, some of which are not hosted in the sigs.kh.io. OpenShift also has an implementation of cluster API,
which is very interesting.
Yeah. So with OpenShift, you can actually manage the deployment of your OpenShift clusters in this way. With OpenShift, it goes a little closer to like what we were doing at Tectonic. And I think it's actually kind of maybe a little bit closer to what's happening with Talos and some of those things. But basically, when you create a new machine in OpenShift, you're actually creating like kind of the ignition configuration for those machines. And, and it has the ability to interact with your API, like your AWS API, your Google API, whatever API you're actually targeting, spin up a new machine, tell it to bootstrap the ignition configuration that is known for that machine, and then you end up getting like a new machine in your cluster and managing it, handling upgrades, doing all of those things, kind of leveraging the OpenShift cluster API piece, which is pretty interesting.
That's right. Yeah, doesn't it like, isn't that the way, the Tectonic worked, where you created a machine that then that machine created everything for you.
Mm-hmm. Yeah.
It makes sense that OpenShift closely resembles Tectonic, but yeah. But I forgot that's how that worked.
Yeah. Nick and I worked on Tectonic years and years ago. We both, I think, blocked it out at this point, but it was a lot of fun. It's fun.
Back when we were wee babies.
Wee babies. So then I found that Sidero Labs, which is the folks behind Talos and those sorts of things, where they have a cluster API implementation leveraging bare metal, very similar in some ways to the OpenShift side of things, in which you can basically use, instead of like using an API to create machines, right? You would have some mechanism by which you could spin up, you would register those machines in a bare metal way, and then use the Sidero stuff to actually configure those things as they came online, or pick machines that are just sitting there parked and turn them into nodes and clusters and all of that stuff. And so this is a pretty interesting one. I think I could probably like get this one going in about a day. It looks pretty fascinating, and I might eventually kind of play with it, but I haven't decided to play with it yet. It is pretty fast. It is pretty neat. And it reminds me a lot of like the Tinkerbell API or the Tinkerbell project, which does a similar thing, basically gets you from, like you want to start with like the place where you're installing an operating system on the node, and you want to take it all the way to a Kubernetes cluster. This is a mechanism for that, as is Tinkerbell. They both do a similar kind of entry point at that layer.
Yeah. This would be like very useful if you wanted to like stand up a bunch of like Raspberry Pi clusters, right? To make your own like lab, right?
In fact,
it's also useful for production purposes as well, but for the purpose of the show, right? For lab purposes.
Yeah. And then for the and in their docs, they even say they target like, edge deployments and those sorts of things, because they're trying to make it so that like you bring on machines wherever you bring them on, and you're able to like identify like what those machines will be, and then make them a part of clusters and handle the life cycle of them, etc.
Nice.
The last one in my list is the one that we're going to be playing with, which is cluster API provider KubeVirt. And I wanted to talk a little bit about like what the constraints are that I'm trying to solve, and like why I'm even evaluating all of these different cluster API providers or cluster API implementations or whatever, and trying to determine like why I'm going about this. So one of the things I work on at iSurveillance is sometimes I like spin up Kubernetes clusters to be demonstration clusters. And for the most part, I leverage Kind for this. It's super easy. I could do a Kind config. I can do a Kind create cluster. I can deploy Cilium to it. You've all seen this happen on this show, gosh, dozens and dozens of times. The challenge with Kind is that a Kind cluster, no matter how many nodes it has, they all share, all of those nodes in a Kind cluster share the same Linux kernel, which means that there's like clearly a bunch more science that goes into like how do we actually manage the fact that we're in a shared kernel when doing eBPF programs, right? Because now we have like the domain that you would consider like the domain being like a single node. Now that domain is multiple of these against the same shared kernel. And a lot of the stuff that we do is namespaced, right? So things like hooking into C groups, right? Those C groups are known by the lower layer, by the actual at the node layer. And so the Cilium agent running inside of that container would only be able to see those C groups that are defined within that like parent C group. And so that stuff all kind of works out. So Cilium as a network solution inside of Kind totally works. It's fine, right? Like we can absolutely do all kinds of interesting things, from leveraging Cilium. We can even do kube-proxy replacement. We can do all of that stuff with Cilium on Kind. Where things get even more interesting is when we decide to instrument a different part of the kernel using a different product, like Tetragon. If I wanted to play with Tetragon like instruments the Linux kernel itself, not just the Linux kernel API, like at the application layer, like trying to determine like what process started this and what is the parent process of that process. How can we create a process tree and do all of those things? Oh, looks like we have something to block.
Yeah, I saw that. I was like,
Block user. All right. Anyway, but how do we manage those sorts of things when we have one shared kernel? It means that like every node would kind of see all of the all of that same kernel and be like a little bit confused because now every node sees the world that is expressed by the same shared kernel. So the constraint that I have is that I wanted to be able to I wanted to use some programmatic method for creating Kubernetes clusters that doesn't share a kernel. I want each node to have its own kernel, but I also still want this all to run on my laptop. I still want this to run in a situation where I can like create these things and be really flexible about how I create them, but I want them all to still be local in the way that kind is local, but I want to have one kernel per node. So that's the setup. That's the set of constraints I have. And I was looking at the different projects. I played a bit with Talos. I played with Talos actually has a mechanism in Talos Kettle where it can leverage KVM, and that works. And that's one way to go. Like I found a few others that are actually kind of on the same line. But one that was actually really interesting to me was KubeVirt. And let's jump into KubeVirt and talk about what KubeVirt is for a sec.
Yeah, because Duffy, it sounds like what you need isn't a container at all. You need a virtual machine.
I do need a virtual machine.
How do you instrument a virtual machine, Duffy?
Yes. And so my goal was to start playing a little bit with this idea. So KubeVirt is a mechanism by which we can control the QEMU KVM implementation on a given node or on a set of nodes, right? And so what this would allow us to do is we can actually, leveraging KubeVirt, create a virtual machine that runs inside of a pod. And so now we've moved this abstraction from creating a instead of creating a node that sits inside of a container, I can actually create a node that sits inside of a VM, which is fascinating.
Yeah, that is I shook my head for a second there just because I was like, sometimes like the concept of that breaks my brain. I mean, it actually makes sense, right? But I was like, this node is also a pod. This virtual machine is also a pod.
Yes.
What? Yeah, that makes sense. But
what?
Yeah, what?
And so think about like a different resource, right? So with Kind, you have the ability to do like this, Kind cluster thing that we talked about before. But as you get further and further into the rabbit hole here, what's actually going to happen at the lower layer is that Kind has the ability, or the KubeVirt mechanism, you're going to have a process running on every node, and that process will be able to interact with the virtualization elements inside of your Linux kernel, QEMU and KVM, and create virtual machines for you and constrain them to the pods that you create. So when you create a KubeVirt VM, that VM is a pod inside of your cluster, and you can manage it the way that you would manage that pod. You can stop it, restart it. You can set its constraints, how much memory, CPU, those sorts of things. Those things are available to you in KubeVirt. And so with this as a layer of abstraction, this is where I was like, you know what, I want to try this out. I want to see if I want to play with like the KubeVirt cluster API, which does in fact exist. So we've been chatting about this for about 44 minutes. So the next bit here I'm going to get into is how do we actually go about creating this stuff. So we're going to play with it and we're going to get it going, and we're going to see if we can actually create a Kubernetes cluster leveraging KubeVirt, and just get started here and see what this looks like.
Yeah, I promise I'll stop distracting you.
I like the distraction.
So full disclosure, I was not able to get KubeVirt working on my laptop, and I think I've realized why. I don't have KVM or QEMU installed.
Nice.
That was probably why it didn't work. So heads up, it's not documented, but you should have some form of virtualization installed on your computer before trying this.
Yeah. So on my machine, I have KVM and QEMU stood up, and I've actually been using the vagrant libvirt mechanism, right? So vagrant libvirt lets me create vagrant machines, but leveraging KVM and QEMU instead of actually instead of VirtualBox or any of that stuff. So on this machine, I already have QEMU and KVM already installed. It's made available. If you run the KVM OK command, you can actually see that KVM acceleration can be used, which means that, like, so for example, CPU info. Inside of here, I'm actually enabling virtualization. So you have the VME, you have a few other flags turned on in the kernel, which enable us to do virtualization of this layer. So that means I can actually create virtual machines. This is a fun one too because I'm using an AMD kernel. This is an AMD Ryzen Pro 4750. So let's take a look at how we're going to go about this. First thing I'm going to do is I'm going to create a kind cluster, and I think I'm just going to. This is going to be my management cluster. I'm just going to create it with, like, I don't actually need these things right now. Get rid of them. So I'm going to create a 2-node cluster, 1 control plane node and 1 worker node. And then I'm actually not going to deploy a default CNI because I want to deploy Cilium onto it. So that is my kind configuration. And if you're curious to learn more about kind, you can go to kind.sigs.kh.io or check out any of the other episodes in this show or on TGK. We all use it. It's a great tool. But I'm going to go ahead and spin this cluster up. What I'm doing here is I'm actually setting a particular image. I'm just using one of the older, like 124.4 images instead of the current top of tree, which is like 125.3, I think. And it's just to basically make it so that it's more compatible with everything. I could use the latest for this as well. Sometimes I've heard it's good to pin your dependencies, you know.
Yeah. Oh, hey, what a crazy idea. It's also common for production users to do 2x latest. So like 123 would be like what most people are on right now. I wouldn't be surprised. Just to make sure that every security hotfix is like filtered its way to it at that point.
Correct. Yeah. All right. So now we have our cluster. We have our kind cluster. If I do kubectl get pos -a, I can see, you know, stuff running, but I can also see that there is no CNI deployed. If I do kubectl get nodes, there's no CNI, right? So let's go ahead and get that deployed. So we'll do Cilium install.
Oh, but Duffy, you got kubeproxy installed.
That's fine.
Okay.
This is our management cluster. We could do it without
kubeproxy.
right.
Yeah, it's management cluster, not the
and it has actually detected that kubeproxy has been installed, so that's kind of cool.
Yeah.
So we'll get that going. And then the next thing we're going to do is we're going to go ahead and deploy some other stuff. So Dan Finneran is a good friend of mine, and I'm a big fan of KubeVip, which is a project that he has put together over some time. So what we're going to do is we're going to deploy KubeVip to this cluster now that it's installed. So the first thing I'm going to do is deploy the KubeVip cloud controller, which is going to handle the implementation of load balancing. But before that can actually work, I need to be able to provide KubeVip a range of IP addresses that it can use to hand out load balanced IP addresses. And this load balancer implementation is actually super important for KubeVirt because when KubeVirt creates a new Kubernetes cluster, it's going to put behind a load balanced IP the API server so that we can interact with it. So I need to have some load balancing mechanism inside the cluster for me to really proceed. Now, what IP addresses am I going to use for the actual the load balanced range? And the answer to that question, Docker network kind. So there is a Docker network called kind that these VMs are hanging off of. And we can see that the range for that network, the IPv4 range, is 172.18.00.16. And it actually does kind of pull sequentially. So it's going to pull like the first ones, right? So here's a VM, our cluster control plane, and our cluster worker, our 1718 or 172.18.02 and 172.18.03. So because it's a 16, I'm just going to grab some of the stuff out of that 100 range, which is not going to conflict, but it will be in the same network. And when I do that, that's going to tell it that the range to use for VIP addresses are 100.10 through 100.30. It'll be on the same network. So from my host, I can still address all of those load balanced IP addresses and interact with them.
Sure, that makes sense.
And then we have to actually install, as a daemon set, the kubevip daemon set. And I'm going to use ARP as the advertisement piece. I'm going to deploy this in cluster. I want to handle services. So let's go ahead and do that.
To be honest, I think this is the first time I've seen kubevip running. Not that it never ran before or anything like that. I've just not played with it myself. And I remember when Dan was building it.
It works pretty well.
Yeah, if you look in the Kube API docs for KubeVirt, they actually do something very similar, but they use the Metal LB project. So if you're trying to follow along at home, replace Metal LB with KubeVip, and you'll be right along with us.
And I'm actually going to put this startup script in here as well. Okay. So now, all right, so there is our kubevip DS. It's running. We have our kubevip cloud provider running. We have that sorted out. So now if I were to do kubekettle, create deployment, echo image equals echo, wait, inanimate. Make this to namespace. Suppose deployment echo type load balancer. Look at SVC, and we can see that we have a load balancer and it is exposed. Copy that, and we can just curl it.
You down with SVC? Yeah, you know me.
And it's working, right? So our load balancer implementation is working well. So we'll go ahead and delete that. And service.
So Sergio in chat says that it looks similar to MetalLB when defining a pool of IP address. Yes, it is very similar to MetalLB in that instance. Yep, kubevip is a great project. If you're familiar with MetalLB, it's not a hard jump to make to use kubevip. Also, something we missed was Sadiq saying hi from Amman, Dubai. It's always fun to see like people joining us from like across the world.
How's
I
it
hope
going?
it's not too late for you.
Yeah, it is very similar to Metal LB. I think that like it may be that, I mean, I know that Metal LB has like moved to like community support. kubevip is still pretty heavily in development, and in fact, Dan Finneran, who's the person who is behind kubevip, we actually just hired him here at Isovalent, and so I'm super excited to be working with him again. And he was, we were just chatting at KubeCon, and he's actually looking at re-implementing a lot of the functions and features of kubevip in eBPF. So that'll be pretty interesting.
Yeah, it'd be great.
All right, so we got our load balancer thing figured out. We need next to, let's take a look at our install doc. Next thing we need to do is we have to install kubevip. So let's go ahead and do that. So I'm just going to copy all of this out here, copy and paste. And what this is doing is it's doing a curl against the kubevip GitHub repository API to determine what the latest version of kubevip is. then it's going to go ahead and install the KubeVirt operator and the KubeVirt custom resource, and then it's doing some waiting to see how things go. So let's do kubectl get pods-a w. And this piece that I'm deploying now, this is actually going to be the piece that's handling the creation of infrastructure, right? So this KubeVirt piece that I'm deploying, it's going to actually stand up an API that's going to be in front of things. It's going to stand up like the individual workers that are going to interact with the QEMU KVM on the Linux kernel that I have in my laptop and create virtual machines that will be the formation of our Kubernetes cluster. So I need to stand this up. This is like, conceptually, if you think about the way that we were talking about cluster API before, we go to concepts here. So these pieces, right? This AWS, Azure, VMware, this one for me is going to be KubeVirt. And what I'm standing up in the cluster right now is the API that is going to be interacted with when I say I want a new machine. This infrastructure provider is KubeVirt for me. That's what's actually happening now, is that I'm just kind of installing that component. See how we're doing. Looks like everything's running. We have our operators, we have our controllers, we have our APIs. This guy's not quite there yet, but it's pretty close, I think.
To what does it handle, the Virt handler?
Virt handler is actually the thing, I think, that is interacting with. There we go.
Oh, I gotta update that.
All right. So now let's take a look at our pods again. See, everything is running. Everything is in a running state. We got Cilium, we've got KubeVirt, we have the one handler, everything is happy. Now for the fun part, we've got all of our basic infrastructure. Now we're going to deploy cluster API. We're going to turn this into a cluster API cluster. This is going to deploy a few things as well, right? This is going to deploy all of the cluster API controllers and those particular pieces, and it's also going to deploy the CAPK, or the cluster API KubeVirt controller, which will handle the interaction between, or translation of, things that are known about by cluster API and things that are going to be needed to know about by KubeVirt. So when in cluster API, when I say create me a Kubernetes cluster, it's going to go about creating the control plane and the workers and all of those things, and that's all going to happen by the cluster API controllers making calls to, or the cluster API KubeVirt controller making calls to the KubeVirt API to create those machines.
And correct me if we've already discussed this, but KubeVirt uses kubeadm to do the stand-up of the cluster itself?
So you can pick a variety of different providers, or bootstrap providers, but by default, the one I'm going to be using is this kubeadm one here.
Okay.
And
that's part of cluster API I haven't jumped into yet, as the bootstrap provider.
So we've installed this provider, infrastructure KubeVirt. It's now sitting in the CAPK system namespace. We've installed the cluster API provider. We've installed the bootstrap kubeadm piece, and we've also installed the control plane kubeadm piece. Right? So this enables us to actually create Kubernetes clusters and all of that stuff. Now, it even says like what to do next. Let's go ahead and create you a cluster, right? It says you want to do a cluster kettle, generate name, Kubernetes version, cluster API. I have done this part, and it looks like this. Nope, not like that. Let me just delete that real quick. Here is our definition of a Kubernetes cluster leveraging the KubeVirt system, the KubeVirt mechanism. And this is kind of where we start getting into kind of the more interesting pieces and parts of how to spin up a Kubernetes cluster. Now, this is a quick start one, right? So I'm not really doing anything super special. I haven't defined anything particularly interesting. I'm just letting it kind of do its own default. So this is going to deploy into the default namespace. The CIDR block for pods running inside of this cluster is going to be 10.243.0.16. The CIDR block for services is going to be 10.95. We are going to use a kubeadm control plane. We're going to use a KubeVirt cluster for the control plane. And then down on the infrastructure layer, KubeVirt cluster is going to be created. It's going to be called Cappy Quick Start, just like it is here. The control plane service template, we're going to actually tell it that it needs to use a load balancer to expose itself. A little bit further down, we get into the machine template. This is where we're actually creating the VMs itself, right? So the memory for these guests is going to be 4 gig. They're going to use 2 cores apiece. The disk is going to be VirtIO based, and it's going to be a container volume. And here we identify the image that's going to be used for this version of this is going to be the container image, Quay.io capk Ubuntu 2004 container disk. This is the actual file system that is going to be used for the base file system of all of our VMs, whether on the control plane or on the worker. And I think if we dig further down here, we can see other interesting things. Like we know that VM, that Docker image, is leveraging containerd. So we tell it in node registration that the CRI socket for containerd is located here on those file systems. And then I think there's one other piece that's interesting. Container image. I guess we don't specify it here, but there is also, I guess I'm curious about this.
Yeah. The KubeVirt machine template?
Well, inside of here somewhere, we're defining the kernel that's going to be used.
Oh, that is interesting. I thought that was based on the image that you're instantiating.
That's just the file system.
Oh.
So in the machine template, there must be some way that it's actually just defaulting to a particular kernel. But let's kick this off and see what happens.
Yep.
So we created a number of resources that we were just looking through. We created the cluster. We created a KubeVirt cluster. These two are paired, right? So remember that at the high level inside of Cluster API, when I say I want to create a cluster, I just tell it I want to create a cluster, and then any additional parameters will be created by the pieces below. So this KubeVirt cluster is being created because I'm defining a cluster. This machine template is being defined here. kubeadm control plane is being defined. KubeVirt machine template. Let's take a look at that one actually real quick.
Yeah, I'm in the source code looking at the specs.
So there's the file system. But where is the kernel? I know it's actually defined somewhere. I'm looking at the KubeVirt machine itself.
Mm-hmm.
And inside of here, this is the file system. VM provisioned, waiting for bootstrap data. Hey, we got a virtual machine.
Nice.
It's cool. So this is actually, the result of those API calls, right? So here's the QEMU KVM executable, default CAPI quick start control plane node. That's our control plane node, is the name of the guest. It's got a master key. Very, very cool. Get machines. Running and running.
You're up and running?
I'll describe. Wait. Machine. Start control plane. Kubelet version. Maybe it is on the file system. Maybe I'm just tripping. All right. Well, we have created our cluster, so let's interact with it a bit, right? So next thing we're going to do is we're going to do cluster kettle. We're going to go ahead and grab the kube config that was created as part of generating this cluster. Since we're in the default namespace, we don't have to specify a namespace, and we're just going to output that kube config here. So if we take a look at that kube config, just pretty standard kube config. We can see that we use that same load balanced IP that we saw before. It's the first one in the set, 172.18.100.10, 6443. And we should be able to export kube config equals kube config, kube kettle get nodes. There's our cluster. We have one control plane node and one worker node. And we can see they're in not ready state. And if we just take a closer look at the kube kettle get pods-a, see kube proxy was deployed. We didn't skip it, but we do not see a CNI. And so just like we did before, we can do Cilium install. And now, basically, each of these is running its own kernel. Each of these is running its own, like these are VMs for all intents and purposes. This is two QEMU KVM VMs running with native virtualization on my laptop.
That's really awesome. This is really cool.
So with this, get pods-a. Cilium is running, core DNS is rolling. We have managed, so if we do, let's see, kubekettle get pods-a, get machine, oh, unset, let's see, unset. So these are our two KubeVirt launcher mechanisms for these guys. What I'm curious about is what happens if I do describe that. Describe pod, virt launcher, control plane. So we see the virt.io virtual machine. It's in an unpaused state. We have a container disk that's been generated. We have cloud init. It's all the user data being created here. Very cool.
So just letting you know, looking around the code base a little bit, In the KubeVirt API, there is a kernel version, but that's for status purposes.
Ah, I see. So maybe that's what it was.
I
that
so
was
far haven't
confused
seen
by.
a way, to specify exactly what version. I think it's much like an AMI in AWS. It's probably going to be based on the image that you pull in.
That makes sense.
Mm-hmm.
So one of my next tasks is probably going to be to pull this to update the kernel and make a new image for my own use for this.
Mm-hmm. Spread them around
What
a
if-
little bit because you want to have multiple, right? That's the idea.
Yeah. What happens if I try to exec into this?
No, it works.
But this is actually my local kernel. This is still my local kernel.
Yeah. So do you name dash A in your thing? I just want to see. Yeah, 5.15.78.
That's an Arch kernel, not a
Right. Yeah. Okay. Yeah. I should have known that.
But I have this cool command, which you've probably seen on the internet at some point. And what this lets me do is it lets me basically lets me kind of take over a node. So I'm going to try using it to get into the node directly. Get nodes. So those are two of my machines. And actually, if I do -o wide, they have pod IPs, which is fascinating. Mm-hmm. Right. So let's do this. Let's do it's root.
Oh, you can see their kernel. They're using 5.4.
Right. So that's that's what I was expecting to see.
There we go. Okay, yeah. Hack one.
So it is working.
Yeah, because you see if you do the O wide on the far side, it has to loop over, but it'll tell you in the status.
Yeah. But now we're inside the VM. And if I do -a, I can see that it's here. And I do dfsh, and I can see the whole file system. System D is running. This is the VM that we're in. CRI kettle PS. Those are the VM. Those are the things that are running here. And then cd boot kernel. Yeah, that's the 5.4 kernel that it's operating on.
Nice.
So that makes sense. Mm-hmm. Okay. So that all makes sense. Here's a big question. Cool. Sure. Probe, is it? Hey. Oh, check it out.
Yo.
Helpers are in. So this kernel actually is BPF enabled.
That's great.
Proc.
Which makes sense. I mean, it's 5.4.
This kernel BTF data. There it is. Neat. All right.
Yeah, that's awesome.
So that is cool. It's a 5.4 kernel, which means I can do some things with it, which means I could do the Tetragon install and play with it. So that's actually really cool.
Yeah, that's awesome.
So there we go. That is kind of what I was looking for. And then the benefit of this is that now I can actually manage these clusters programmatically and start playing with things like Flux and those sorts of things, and start managing what's actually happening inside of these clusters. I could even use Cilium to do like a what do you call it, a multi-cluster kind of situation, which I think we're going to explore next time because it's 12:14. But that is enough to get us started.
Yep.
That definitely shows me, and I actually wonder how long it'll take to delete this stuff. So if I do kubectl delete -f copy quick start, what happens? On set big.
Another thing you can do, I found, is just there's a cluster CRD. If you do delete cluster, it'll take care of that for you.
That's true.
Yep. Also, Sergio says, in the KubeVirt documentation, there's a section boot from external source. So maybe that's another mechanism for...
boot from external source.
I'm going to try and find that. Or Sergio, if you have a link for that, please drop in the comments.
Oh, is this the KubeVirt side?
Yeah, it's on KubeVirt docs.
That sounds more like a SCSI thing.
What'd you call me?
Oh, I see. Yeah, that is interesting. So in the virtual machine, you can tell it firmware, kernel boot, container, image, and then the init path and kernel path can be a different path than the image.
Huh.
Define the path for binaries inside the container. Yeah, that is pretty cool. Okay. Cool. Well, on our next episode, I think what I'm going to want to do is I'm going to want to get a version of the KubeVirt. Let's see, it's KubeVirt cluster API. There's a thing inside of the KubeVirt cluster API mechanism that's called the image builder, and they describe that. Well, I thought they described it right here on this page, but I don't see it at the moment.
But presumably, you're going to use that to build one or more custom images, and then spin up a bunch of KubeVirt.
Correct. Yeah, I want to be able to. I want to be able to manage the. I want to be able to handle the. I want to manage the images myself, including I want to be able to pull in a different kernel. And so I think I have to actually build my own cluster API KubeVirt image. And so I'm going to work through the docs on how to go about that. And then probably in our next episode, that's what we're going to play with.
Sounds good. If you want some help, I have built custom cluster API controller images.
Very handy. Good to know.
Not with KubeVirt, but I've gone through the process before. So yeah, this was a really fun episode. It was really cool to walk through the different cluster API and all the different things. Everyone, if you want to do everything that Duffy did manually, just stand up Minikube and then use Minikube to stand up a bunch of different ORQ, AMU, or KVM. I was surprised there isn't a cluster API Minikube, because Minikube also spins up VMs, right?
It does, and it actually leverages kubeadm under the covers.
Wow. Yeah, exactly. So hey, crazy. So a little bit surprised there isn't a Minikube cluster API, but yeah, so spin up a bunch of Minikube instances, and then manually work those together into a Kubernetes cluster, or just use cluster API KubeVirt, and it does pretty much the exact same thing.
I wanted to put the install script in here, so that people can actually
into the eCHO repo.
Yeah. Boop. There we go. So that is the install script I was using to handle the installation of all of this stuff, installing Cilium, installing KubeVip, installing cluster API, installing cluster API, installing KubeVirt. And it got me pretty far. And then if you tune into our next next episode of this series, we're going to build our own custom image with our own custom kernel. We're going to be playing with that kind of stuff, and we'll talk about it then. So thank you all for attending, and we'll see you all next time. I hope you all have a great holiday week next week. If nothing else, it's just a great opportunity to eat with other folks, and that's just not an opportunity that should be missed. So have a bunch of fun. I'll talk to you later.
Right.
Let's see, Brad. And
Bye.
Bye.